Hey, good afternoon. We're just a few minutes away from the start of our webinar. Just give us a few more minutes and we'll get things going. Thanks for attending. Just another minute or two and we'll go ahead and get started. Thanks for hanging in there. All right, good afternoon. Welcome to today's webinar, Design Best Practices for Tube Bending and Cutting, presented by Xometry and hosted by Metal Forming Magazine. I'm Brad Kubin. I'm the editorial director of Metal Forming at the Precision Metal Forming Association, and I'm pleased to be today's moderator. Before we get started, just a few notes about today's Zoom meeting session. This meeting is being recorded for archiving, and the recorded event will be posted to our website within the next day or so. We'll let you know via email when the recorded webinar is available for viewing online and for sharing with others at your company. Also, all of the participants in the meeting are in listen-only mode. The speaker and other listeners, therefore, will not be able to hear any audio from your site during the program. However, you do have the ability to communicate with us throughout the program by submitting any questions and comments using the Q&A panel, the link which is located on the bottom of your Zoom screen. And then after the webinar, you'll use that same Q&A link to ask questions of our speakers. All right, so now it's time to begin today's webinar, which is intended to help manufacturers optimize their tube bending processes with advanced technologies and best practices to ensure precision, efficiency, and cost effectiveness. With the integration of AI and machine learning in Xometry's instant quoting engine, tube bending manufacturers can access instant pricing, real-time lead times, and critical design feedback. So now it is my pleasure to welcome today's speakers, Greg Paulson, Director of Applications Engineering at Xometry, and Solution Sales Manager, Tim Stouffer. Greg, it's all yours.
Hey, thanks so much, Brad. And I really want to thank Brad and the Metal Forming team as well for having us for this webinar. We're really excited. We got a lot of content to cover, and it's a cool subject. Talking about laser tube cutting and tube bending. So I'm going to jump right in. First off, we're going to introduce who we are here, the team here, myself and Tim, in just a moment here. I'm going to tell you also a little bit about Xometry, what we are, what we do, and show you some of the tools that we have, especially the instant quoting that we've just advanced for tube bending and cutting. I'm going to do a live demo about that. And then really the bulk of this is going to be on those design tips. We'll start with laser tube cutting, and then we'll go into the complexities of tube bending. And we're going to finish up with some guides, resources, and talk over Q&A. I'm going to echo Brad as well. We love answering questions. Like Tim and our full-time job is answering questions about manufacturing. What should I do? DFM feedback, help me choose and why. That's our entire world. You can ask questions throughout the webinar using the Q&A tool, and we'll get to as many as we can at the end. And for those we don't get to, I promise we will get back to you. So just ask away, please, please. So I'll start with some introductions. I'll start with myself, and then Tim, I'll let you introduce yourself as well. My name is Greg Paulson. I'm the Director of Applications Engineering at Xometry. And I've been working in advanced manufacturing for the past 15 years, starting off actually in additive manufacturing, so 3D printing on the industrial scale. But I've always worked in an integrated cross-disciplinary product development area, working across CNC machining, sheet fabrication, and injection molding and formative processes, and tube and laser tube cutting is something that I've been a sponge to. So I've been learning with team members like Tim here, Tim, if you want to give an introduction now.
Yeah. Thanks, Greg. I appreciate the introduction. So my name is Tim Stouffer. I'm the Solutions Sales Manager at Xometry. I'm actually a newer employee. I am working on 3 months here. With my focus and my role really on building our tube bending and tube cutting business, specifically improving the auto quote functions, and also improving our manual quote team, which we'll talk more about throughout this presentation, and our partner network, which we'll tell you more about as well. So a little bit of my background is I have 18 years of tube industry experience. Most of that spent with my former employer, who was an OEM that designed and manufactured tube components for the power generation industry. I spent 13 of those 18 years actually managing one of our pressure part facilities that focused specifically on smaller production job shop environment, but very tube focused, tube assemblies, tube welding, some metal forming and other processes associated with it. So that's me. Happy to talk with you all today about all things tube and how Xometry can help you.
Yeah, and we're super excited to have Tim on board as well and have him along for this webinar. Just every time we look at our manufacturing processes, we want to make sure that we're talking from experience and we're working through problems, because we're solving real problems every day throughout Xometry. And Tim's been vital as we've been launching and celebrating and doing the work within the tube industry. So I do want to go backwards a little bit and talk to you a little bit about what Xometry is. Xometry, we are a digital manufacturing marketplace. What does that mean? For customers, for people who need parts, we're the first place you go to get custom parts manufactured. For suppliers, we're like an Uber for manufacturing. They're able to see work on demand based on work that is generated through our online instant quoting engine. Xometry, we are serving over 60,000 customers. So 60,000 customers are using Xometry to procure custom manufactured processes over dozens of manufacturing services. And we have a domestic and global supply chain to manage that work. So we work massively in parallel. And we solve a lot of these supply chain and procurement needs and de-risk sourcing because of a distributed manufacturing network. One of the things that sets us apart is we're not just brokering. We are real people. We're investing in your designs. We have a QMS system in place to make sure that we're assuring the quality and delivery and timeliness of all the products that we produce. So I'm going to kind of talk through a little bit about how we do that and show you this in a second. But this is kind of the overall schematic. We are a two-sided marketplace. So like I said, the buyers are those who need things made, the suppliers are those who make stuff, and we build this bridge and connection using AI and machine learning at the core of our business. We use computational geometry. So when you upload a file, it would be in a 3D CAD file format, for example, for a tube bend part or machine part. And we use instant quoting using AI tools to interpret that geometry, provide pricing, DFM feedback, and lead times in real time. So that pricing takes seconds versus days or weeks, like people may be used to at a typical RFQ cycle. And for customers, that means I get instant pricing lead times. I can make a buying decision right then and there. For suppliers, when they press buy, that work is networked to suppliers based on their capabilities. So a project like this is a great match for a supplier like this. And we use prior work and actually use machine learning and AI to do that matchmaking on the supplier side. So it's a really powerful and very, very scalable business model that's helped us really expand across all industries. And we've expanded our processes. So this is this is the short list, if you will, of the major processes that we offer: machining, sheet metal fabrication, molding, 3D printing, our bread and butter. We've introduced tube cutting and bending, which obviously we'll be talking a lot about today. Laser cutting, stamping, and other formative processes are also what we work with. So whether it is a one-off or you're doing a customized project that is end use but maybe low volume, we could handle that. But we also scale with your needs up to serialized production and beyond. One familiar name for you may be Thomas. So Thomas is also part of the Xometry umbrella. So Thomas is essentially a manufacturing directory that hosts over 500,000 direct suppliers across 76,000 industrial categories. So again, our encompassing business value is we want to be the first place you go to get something made because we have the resources to do that and help you find that right manufacturing solution. But we're talking about tube today. So we're going to go into tube subject now. Hey, who figures? And when I think about tube, I think my summary is usually when I use tube when I'm trying to make large structural parts. I'm looking at my desk right now. My desk is made out of square tube that's bent and welded. All around you see products made out of this, and it has a very similar feel to me as you do with like sheet metal, where you're using a common stock material, and then you're using forming or cutting tools to make the customization of it. But because you're using this common stock material, you're able to keep your prices low and really utilize and reuse tooling to make something truly custom through that. And that differs a little bit from like CNC machining or something where you're hogging out a lot of material and there's a lot more overhead involved. Where with these formative processes like tube and sheet, I have this ability to essentially reuse that tooling and duplicate those parts much more efficiently. So once I have it set up, I can just keep on going with this. And yeah, Tim, if you want to jump into your world a little bit, but we do, there's so many applications into manufacturing.
No, that's a really good point. And I mean, you list a lot of what our current market demand is coming to us for, but day to day on the quotes I review with our manual quote team and reviewing what we see that comes through the auto quote platform. I mean, there's applications for fluid transfer, pressure applications, a lot of prototype work. A lot of hobbyists come to us. Maybe they're early on in their prototyping and design for whatever product they're trying to design. And we actually have started to see some production requests too, so higher quantity. So it's really all over the map, Greg.
Yeah, absolutely. And I mean, like I said, it's a very utilitarian product, and the markets that you hit are everywhere. I mean, there's not too many markets that aren't using tube products in some way, shape, or form. And I want to show you a little bit about the experience here on what Xometry has and tell you a little bit about our site. So we're going to drive into the instant quoting engine to kind of show you what we've done as we've incorporated AI and machine learning to this. And we're really excited about this launch. This is the newest technology vertical that we've added to Xometry's platform. And we've done so much because there's nuances. And a lot of these we're going to go over today with these design rules and principles. But there's nuances when you think about tube manufacturing design that we want to address upfront to prevent downstream issues in the manufacturing cycle.
Mhm.
So I'm going to Alt Tab here, and Tim, you're going to verify that you see the word manufacturing on demand now, right?
I see manufacturing on demand. Yep.
Great. Okay, good, good. Okay, so we're so far so good. This is the fun thing about live demos, right? Is what actually happens here. But this is Xometry.com. I'm on our live site. I've already logged in. So Xometry, this is this is a platform for our digital manufacturing marketplace. Our homepage has a bunch of resources that are available to you, and you can learn more about our processes as well. I'm going to show you the instant quoting engine in just a second, but I do want to show you some tube related stuff while I'm here. So under our solutions, you can see all the different manufacturing processes that Xometry offers. If you're looking to learn more about a process, you could click on the capabilities links under the solutions and get some more information about these processes, materials, offerings that we have, and even find things like design guides or start
Mhm.
your quote directly here. The other thing I'll say, because tube is something where we're taking a stock material, so under our resources tab, we have a standard tube size resource here that's very, very useful when you're looking through. That being said, we're talking over 1,000 different configurations of tube available for instant quoting. So if you're already designing it, we probably can already quote it, but this
Mhm.
is a good sanity check as far as looking for what we're instant quoting. That being said, let's jump into get your instant quote. So this is the dashboard. If you haven't used Xometry before, we kind of start you off with a secure login. So you're logged into your account. We are looking for 3D CAD files. So you can see the different types of CAD files that we are able to accept. Most major types are accepted within Xometry's platform. And you can upload those files. And as you upload those files, it also builds a digital library for you. So you can go retrieve quotes that you've made in the past, as well as retrieve those files and quote them again without needing to upload them in the future. I'm going to go and click to choose a file here. And I'm going to go and take this mandrel bent tube component, press open. It's going to ask if this has any export control or restrictions. If you are working on defense related items, ITAR is a checkbox away. So this one is not ITAR, but if you do have any of those requirements, just check this and it'll take you through the right pathway and you'll still be accessing instant online quoting. So I am clicking this and we're moving forward, and just give it a second, let it digest here. So what's happening? This tube shape. First off, our AI machine learning is basically looking at this item and saying, what is it? Is it machined? Is it 3D printed? Is it tube? And it's helping categorize. So it's going to be looking at these features and figuring out, is it tube in the first place? And if it's tube, is it laser cut? Is it bent? What type of features are in here? And I have uploaded this file, and I've uploaded this file. I have this identified as tube bending, but, and I did this on purpose,
Mhm.
something's up. So I'm going to
Something's
click in
wrong.
here and look at the analyze really quickly. So one of the most important things, like I said, is there's things that we'll talk about today: centerline radius, distance between bends, tube stock size. We are actually looking at that and comparing it against design best practices. So I could take a look at this really quickly and say, hey, that's not a standard outer diameter for this type of tube. The distance between bends has an issue here. And the bend radius, I have a different centerline radius. All of these we'll talk about in more detail, but I want to show you this digital check here because something's up. So I'm going to go back into my quote here, and I'll revise CAD in just a second, but I'm going to go edit my configuration. I'm looking for A513 DOM here. Save my properties really quickly, revise my CAD. And we use revision control systems here. So now I'm replacing this CAD, and it's going to be reanalyzing this part. So I wanted to show the DFM first because it's really cool to see, like, oh my gosh, why is it not quoting? And then you could go take a look. It's like, oh, here's why.
There you
And look at that beautiful green checkbox here.
go.
So so with this uploaded updated file here, we're checking the bend radii, we're checking the bodies, we're checking the availability in A513, looking good for this. Everything looks fine, and I'm getting my instant quote.
Mhm.
That pricing and lead time is real. This is not an estimator program. This is buy it now. And so you as a customer, can continue the checkout, or you can continue to your configurations of this quote. It's going to ask for a drawing. So like I could upload a PDF drawing here, but it's say instead of asking your vendor, please quote, 1, 5, 10, 30, 50. If you need 17, just type in 17. And your pricing and lead time updates automatically. You'll see the amortization of pricing available right here. You can see that this is going to be made in USA, and that is my purchase price. I could add other needs like custom inspections. If I have different shop certifications required, I could click on those. And if I do have any other requirements here for custom manufacturing, Tim was mentioning the manual side of this. If we do have those needs, you can write in your needs here, and what's going to happen is that'll give us to our team to review. I wanted to show that really quickly before we get into the bread and butter of the design best practices, to show you that we've incorporated a lot. We're basically eating our own dog food. We've incorporated our design best practices into our instant quoting experience to make it streamlined for you as a designer or someone who's looking to source those custom tube parts. I'll take a breath for a second as I alt tab back here, because quoting demos are that went smoothly, and we're always happy in the Q&A section if you want to game storm something and say like, what if, I'm happy to jump back into that as well. So we mentioned tube types. I should also show it on our website where you can find the drop-down menu of available tubes for our instant quoting. Right now we're looking at round, square, and rectangular tubes. And the common alloys are going to be the 304, 316 welded like seamed or seamless tubes, 6061 a chromalloy, so 4130 chromalloy for which is usually more for structural component design, and the bread and butter steels that we have like A513, which comes in different. They're produced in different ways, like hot rolled electric welded, and which is HREW, for example. There, DOM stands for drawn over mandrel, and CR is cold rolled electric welded. But a wide variety of tubes available.
Yeah, and we keep in mind too, this is our auto quote platform. So if there's another tube or a grade or a size that you don't see, we have a manual quote team available to turn quotes as quickly as possible. Interact with you if you have needs beyond what the auto quote offers.
Yeah, absolutely. We have thousands of manufacturers. We can make it. So the question is not can you, right? It's more like what do we auto quote and what do we manually review. But even with that, one of the problems that we found, and I'll tell you this, Tim, when we launched tube bending and tube cutting, I was doing pricing exercises because I was working on some projects, and my time to get an RFQ response with vendors I already had a personal relationship with was 3 to 4 weeks.
That's not uncommon. I've experienced that myself.
and I'm like, I got your cell phone, man. And the fact that we were able to digitize that and automate it so it's in a matter of seconds is pretty amazing. And it's we're really, really excited about being able to do that. We're going to jump in to tube cutting first, because tube cutting is more simple than tube bending. You'll see here, but it is very, very exciting technology for scaling up the work that you're working with a tube. And so the tube cutting that we're talking about at Xometry, so when you upload your file and you press buy, we're talking about laser tube cutting in the service. And this is because it is a very, very scalable, very repeatable, and automated way. So it's an advanced manufacturing, advanced technology way of making tube parts. I'll show a video right after this to show you a little bit about how the parts are chucked up and how they move around under a laser. But it's a very, very automated process. Low material wastage. You're actually cutting from that tube, and then you can move to the next tube and continue going. It really doesn't really have minimums to it, especially with standard stock sizes. You're just buying that space that you have on the tube, and it's clean and repeatable. It also works with nearly every metal. We are instant quoting metals up to 6 inches in diameter. But tube cutting machines can be used for other things like channel bar, like C channel and L channel bar can also be cut with tube cutting apparatus. So anything that can actually kind of hold something in that rod shape and create those cuts is something that you're able to do with this machine. So it's a very, very versatile machine for what it is.
Yeah, it's shapes that can have 4 points of contact, basically.
Yeah, absolutely. Because that's, you can see here the kind of how it's being chucked up. You have a clamp out here, and then right behind that's another clamp holding those other sides.
Mm-hmm.
So the componentry of a laser tube cutting machine, and I'll keep on repeating this because first off, it's highly entertaining watching. Like it's probably the coolest manufacturing process to watch. It's very sparky. But you're clamping and holding that tube. It's also going to be pushing the tube in and out against a laser that's going to be moving up and down. So think almost like a CNC style where it's moving the tube around, lasers going up and down, and that's a high powered laser that is making those cuts there.
Mm-hmm.
You can see that this laser is cutting directly towards the center line of that tube. So if you imagine it's always pointing towards the center line, we're going to talk about this in a second, but it's normalizing, or it's doing what we call a 90-degree cut, which will be the most common cut there.
Mm-hmm. Yeah, and that laser there, Greg, that's a fiber optic laser. That's common what our partners use. It's the newer technology, a bit different, more sophisticated, I guess, than like the CO2 lasers that you see in like sheet cutting.
Yeah, absolutely. And we found so CO2, for example, in sheet cutting, I may use that for acrylic or something that's a
Mm-hmm.
small, like a thinner gauged metal. But even that fiber laser's been taking over because what you can do is put a lot of power in one place very quickly and move way faster. Your
Throughput.
throughput is
Yep.
just way higher
Mm-hmm.
with fiber laser cutting. Um, some some basic dimensions to keep in mind for our instant quoting, and again, we could always work with exceptions as well.
Right.
But we're instant quoting round two from 1/2 inch to 6 inches. Same thing with squared rectangular geometries. Wall thicknesses about 35 thousandths of an inch up to a maximum wall thickness of 1/2 inch. So that variety of tube shapes is available, and of course, over that variety of materials that I mentioned earlier. We are quoting with the assumption of a normal to cut surface, which my next slide will go into. And the cut tolerances are very, very similar to laser or sheet cut
Mm-hmm.
materials, where you're looking at that edge-to-edge feature tolerance of plus or minus 10 thousandths. Something to note about tolerances with anything that is a stock material is the tolerances of the stock are outside of our control. Those are dictated by the stock itself. So, for example, that
Yep.
the diameter or wall thickness of that stock is dictated by the OEM, the manufacturer of that material. But they're typically very well documented, and they're not crazy. Like this is a highly repeatable process. But it's something to notice. You can't, like, if you have a specific tolerance call out on that outer diameter or that wall thickness that is outside of what would be normal for that stock, you may be venturing into CNC land or
That's a good point.
grinding or something to that matter.
Yep. Very good point, Greg.
Mhm. So I keep on mentioning this, the normal to surface cuts. If you look at it, if you think about that laser pointing straight down, always aiming towards the center line of your tube there, or towards the center of the tube profile, we call that a normalized cut. It's got a lot of nicknames to it: 90-degree, perpendicular cut, true copes, 2.5D cuts, but it's all talking about the same thing. And we're talking about this because we are talking about managing expectations. When you're in a 3D design state and you're making a model of your tube, very often you're subtracting your tube stock from I got duplicates here. So, but you're usually taking like your features and you're subtracting,
Mm-hmm.
this from this to create this cope design. When you do those, you're usually going to see a sharper edge on your CAD. When that gets translated into manufacturing, the physical manufacturing of the item, because the laser is pointing straight towards that center, you're actually going to have an outcome that looks more like this. Now, this is exaggerated because of how thick the wall is compared to this tube size here to show this point, but you can see examples of the tube cuts where you can see that normal to surface movement as it goes through.
Mm-hmm.
It's important to know when we think about the expectations and the fitments, especially if you have some very, very high angled cuts where you have these knife edges in your CAD design, we're automatically going to compensate for that within our cutting it normal to surface. I have some visual examples here to show what that looks like. But if you imagine I take this tube and I'm in my CAD design state, I'm extruding those shapes through or extruding that miter as a diagonal. going through that round or that square tube. When we interpret that with a normal surface, what the machine's actually aiming for is that inner profile of that shape. So it's aiming for that hex. You can kind of see the pink here. It's aiming for that square. But as it's doing that cut to aim for the inner profile, the way that it's going to be twisting that bar towards that, as well as keeping that 90-degree, is going to give you this more of a flared look if you look at the actual features from the outer to inner. But this could be good. By the way, this is actually a lot of times if you're receiving tube, and Tim, we talked about this the other day, like it's when you're adding these together, a lot of times you are either grinding or creating tube features, so you have a space to weld it into. So you kind of see on this design here what that looks like.
Yeah, especially for welded applications, it provides I guess a prepped fitting for good joint penetration.
Yeah, absolutely. But this is something, by the way, we do have CAD design resources, because as we were launching Tube, I was like, how do I design that? How do I look at that in CAD? And we actually have design resources around how to simulate, actually, how to show and normalize your tube in your design. So when you look at your final assembly, you have a better expectation about how that's going to look and how that's going to interact.
Okay, yeah. So we looked at, the normal to surface cutting. So let's talk about some of the design guidelines that will help you as you go through, your design process of your parts and implementing this into our AutoQuote platform. So some of the additional guidelines that you want to keep in mind as you design your parts is there really isn't many shapes that a laser can't cut. They're very capable machines. CNC has really changed repeatability. Um, one thing to First thing to keep in mind though is your minimum feature size. We recommend that you keep that at least 1 times the thickness of the wall of the tube. That's the minimum. We like to shoot towards more of that 1.5, or even if you can, higher. That just allows the machine to work better, and you have a higher opportunity to have a good part. However, when you get into thicker tubes with thicker walls, you want to lean more towards that 1.5 as your minimum and go up from there. Let's see here. So the mitered cuts that Greg mentioned earlier, that is something that you're not going to essentially get what you designed, I guess, is a good way to look at it. You lose that sharp edge. So that top picture there really kind of shows where that sharp edge is cut off. We mentioned earlier, the nice thing about that is if you are welding those two pieces together, that is the start of a good joint prep, a joint configuration that any welder would love, because that will provide a nice penetration, structural integrity in your weld. More helpful tips that you want to incorporate when you're designing is the indication feature. So you can cut notches into your tube shapes. So when you're putting things together, you have an indication. It shows you where this part goes. Looks like Greg might have an example there.
Yeah.
There you go. Yeah.
This is free. This is basically free, So
Yeah.
if you're still thinking bandsaw design, you can get a little more creative with when you're thinking laser tube cutting.
Yeah, so who's ever constructing the final part or whatever it may be, those indications are a great way to make sure it's put together appropriately to maintain your geometric sizes and your dimensions associated with that part. Also note, we go back to this plus or minus 10 thousandths nominal tolerance. And once you start getting less than that, Greg mentioned it on the previous slide, you start getting into additional processes like a CNC or a turning operation or something else associated. As you add processes, your costs go up. It's not that we can't do it. It's just it's not going to be as economical price for tube cutting. One of the other things that's also pretty sweet with laser tube cutting is that you can actually put text into tubes. So this could be through text. You cut through the wall. We can also do, partially through the wall with engraving. So it's not impeding your applications where you can't cut through the wall of the tube. But a couple things to keep in mind though. Text is like stenciling. All right. When you use a stencil machine, you have to have those bridges to hold, like the letter E, the lowercase letter E needs something to hold that piece without having it float in space. Yeah. So Those bridges, you want to make sure that you maintain at a minimum, a 50% of your wall thickness, just to keep it structural, keep it sound as it's, going through the process and ultimately getting to you as the end customer. Let's see here. I mentioned laser engraving as well. So laser engraving is a great way for part numbering, right? Or adding uh, instructions on the tube, or just maybe even just some swag or branding, right? It's just a really cool option that these laser cutters can cut through the tube, but they can also engrave the tube as well. Then lastly, aluminum, fantastic product. It's lightweight, high strength applications. I think we had a slide earlier that may have showed the difference on the types of
Yeah,
cutting
I could kind of
surfaces.
show
Oh, there you go.
if my camera behaves, but you could see more striation. So when we're talking about slag,
Yeah,
so it's not burrs, it's melted stuff. When
yeah.
you're lasing through, and you can feel usually on the inner surface as the laser's piercing through. It may have a rougher feel. You can actually kind of see a little bit of that roughness right there, because aluminum is it's so
It's
thermally
gummy.
conductive. Yeah,
Yeah.
it'll gum up, where steels and materials that are less thermally conductive, they have a cleaner cut by
Hmm.
nature. And by the way, fun fact, because I work in advanced additive manufacturing, when you're doing metal additive manufacturing, the same rules apply for aluminum 3D printing and steel or stainless steel 3D printing, where you usually get crisper features on the stainless steel over aluminum because of that thermal conductivity there.
Yeah, so keep in mind, aluminum is a great product, great material, but if you're cosmetic, maybe steel is your better choice, or stainless steel. Um, so yeah, moving on here. So the laser tube cutting features to avoid, we talked about how to design your part, but there are some things you want to make sure you take into consideration and even try to avoid. So we're going back to the normal to surface cutting, right? Normal to edge is capable. We do have partners that are capable of doing that. And that basically requires the head of that laser that Greg showed earlier actually has to tilt, has to angle as it's cutting. So it's an additional access for that machine. It's just more expensive. We do have some that do it, but our standard practice is normal to surface. So all of our partner network can handle the part that you're trying to get made. Secondly, avoid small features and gaps. And that includes, like, on your on your font parts. Um, Small holes are just hard to have good quality when you're dealing with a laser. So keep in mind, we mentioned on the prior slide, minimum 1 times the wall thickness. Full length cuts, tubes are round or square. They have a shape that they want to stay. So when you're making full length cuts and taking big chunks out of the pie, you kind of lose you lose the integrity of that raw material. It's also a lot less repeatable, just based on mechanical properties of the tube as you put heat into those parts.
So, so Tim, on that, we haven't made this yet, but it was one of those where prototype before you make 300 of them.
Yeah,
So I've been working on a tube design for kind of a phone holder, just something fun to do.
perfect.
And but this is what we're saying that those avoid. So
Hmm.
my approach, first off, I 3D printed to check if it worked. But then my next approach is to make 2 or 3 of them and see if it holds the shape that I'm intending before we go and cut hundreds of them. Because
Right.
this is so it's not saying we can't do it, but it's something to be mindful of, especially in your
Yeah.
design, because this has a full through cut, and there's a good chance that it may either want to do
Hmm.
this or flare out on
Hmm.
me once I apply that heat and stress to those parts.
Yeah.
I know, like the last one was like wispy and cantilevered
Yeah.
features
Yeah. Yeah.
too.
Same.
I always say the gravity test. Can it hold its own gravity? Like if you're holding it
Right.
from that wispy end, is it going to flex on you? That's something you want to avoid,
Hmm.
because that means that it can be damaged in shipping. It can be damaged by you. There's so many ways for that project to have a fail to it.
Hmm.
Um, but laser tube cutting is fairly straightforward. It's very versatile. It's very much a bread and butter exercise when you're cutting this out. Tube bending itself, though, so we're moving into the tube bending is similar world, same stock. Different rules here because we are forming this shape. When Xometry talks about tube bending, we're talking mostly about mandrel tube and rotary draw bending. So we'll go into details on how that works in a second, but the most important thing about this is we're able to take a tube design with multiple bends and multiple angles and make it. And if you're living in a traditional fabrication world, you may be thinking about tube in a series of straights, elbows, and J's
Mm-hmm.
in your design, and you're buying basically stock components of these straights, these elbows, and these J's, and then stitching them together. So this feature right here would be a straight, a weld, elbow, weld, straight, weld,
Mm-hmm.
elbow, weld, straight, weld, elbow, weld. And so you're consolidating this need for welding. You're creating a more consistent and repeatable experience. Going from 1 to 5, gets cheaper and cheaper and cheaper every single time, versus keeping that same overhead for every single weld you're doing on this. And you get a more consistent product using CNC driven design with mandrel tube bending. We also we would need a manual review, but from roll bending. So we launched with mandrel tube bending for instant quoting, but those center lines over 6 inches or so may turn into a roll bend, or if they have
Mm-hmm.
a an odd radius to them, that may become a roll.
Non-standard.
Yeah,
Yeah.
non-standard. Thank you for the actual words to use there. And the thing that we're avoiding though is compression bending. So I always describe compression as like if you're taking a straw and bending it with your thumbs, you're going to see that pinch point
Mm-hmm.
in that design. All of our bending is done in a way where we're looking to preserve the circularity or reduce ovularity, if you will, of the design in its final state. So we want to hit your CAD,
Mm-hmm.
essentially, is what it comes down to. This is a cool manifold, by the way. This is a design we worked with the fabrication series on for launching tube bending and cutting. And this actually is a sheet cut piece with mandrel tube bent parts, a metal laser sintered junction here, and then a laser tube cut at the end. So pretty fun story. And they did a little YouTube video on that about this. But yeah, Tim, talk about the anatomy. I also have a video of
Yeah.
some of that actually. This is actually that part of that design that you saw in the last image being built here with a mandrel tube bender.
Yeah, yeah, no problem. So we actually get to see a pretty nice video here that not only shows a tube being bent, but also the use of a mandrel and a little bit of setup too. You can see the operator there. So the first component of this bending operation I'll talk about is the mandrel. So Greg can try to pause it here once it gets to the point where you can see the
Yeah,
mandrel.
we'll play this video a couple of times here as I remove. We'll show it all at once here to kind of show the bending operation.
Yeah, so I'll continue to talk and
Yeah,
you can pause it there. So what they're using here is it's called a ball mandrel, and it's basically simply defined in the fact that it has segmented components and they're called balls. Um, the other types of mandrels that are available are something called a plug mandrel, which is essentially the same thing. It just doesn't have the segments. So you can see
yeah.
Greg pause it there.
It's
He
kind of
can,
this little cylindrical thing right in the middle, but
yeah,
it's right at the end of this shaft that the tube is sliding over top of,
yep.
and so it's inside the tube as it's being bent.
So it goes inside the tube and it actually helps maintain the shape of the tube. It reduces the ovality or the oval shaping of the tube during the natural bending process. Um, it actually gives really good quality too. It really maintains that round shape. It also reduces overall wall thinning. You'll see mandrels used predominantly in tighter bend applications where the bend radius is tight and it's a thinner walled tube. The next component we'll talk about is the bend die, and this is actually what sets the center line radius of your design tube. The bend die is that hunk of steel right in the center of that post there. There's actually a post that goes through. There's a hole in the die and a big nut on top to keep everything together. So the bend die is, as I mentioned earlier, it's the actually what sets the radius of the bend. And each time you change the radius on your design, which we'll get into on the next couple slides, a new bend die needs to be put on there. So it's only it's significant to the OD and the center line. It can't do anything else than that center line radius. Um, the last component, which you see the operator actually install here, is called the clamp die. I'm sorry, not the last one, second to last. And so the clamp die is just basically a hunk of steel with a concave cavity in it. And that's actually what clamps the tube to the bend die. So they have a mating surface, the two sides come together and the tube sits in between it. Uh, the clamp die basically just holds the tube to the bend die and during the bending operation, during the bending process, it keeps that point of operation in full contact. And lastly, you'll see this hunk of steel on the back. Same thing. It's like a clamp die, just longer. So the pressure die or the follower block, however you want to refer to it, it provides the backside pressure during the process. So that pressure die actually travels along the bend tangent as the machine operates. You'll see that back.
Yeah, you'll see it slightly
Yep.
move to compensate for stretching.
Actually, so yeah, so as it's moving, what it's actually doing is it moves as long as the bend tangent.
Yeah,
So
as long
it
as you-
follows along the bend tangent, and it continuously provides that back pressure and forcing that tube into the die to help maintain ovality.
And I think this is like what's really important here is like this is very different than the hand bending tools like something you may buy at Home
Totally.
Depot.
Yeah.
And this is where you're talking about where you're looking at advanced manufacturing technology because once you have these tools and setup, you can repeat and repeat and repeat
Hmm.
with this. So it is very, very powerful for multi-bed tubing at low volumes, but it really shines when you're outfitting, outfitting part of your assembly line with these items, or you're making a stock item where you're repeatedly producing these.
Yeah.
The sizes are a little bit different. So I'm on the sizes and tolerances now, but the sizes are a little bit different where we're bending smaller diameter, so anywhere from 1/4 inch to 2 inch diameter. Our instant quoting right now is for round stock. If you're looking for square stock or something bent, you're going to be talking to Tim in a heartbeat there,
Hmm.
because he'll work through. We do have suppliers that could do that, but we had to launch somewhere, and we're launching with round stock for our instant quoting, and similar wall thicknesses to the other guys, 35 thou to about 188 thou, and multiple bends, are something that is just straightforward. The other thing I do want to note is that we can cut with that. So if you do have indicating features for nuts or bolts, at the end of your tube, you can actually just upload that CAD file with the final features that you want on that, and we're incorporating that within the price of the part itself. Everything else is very similar, where you had that normal surface cut, as we're going to be cutting there. And the way you think about bent tube, and from a tolerance standpoint, we usually think of it as a sheath envelope. So if you imagine the theoretical tube, CAD perfect, and the actual tube, we're looking at the deviation of those up to about a quarter inch, or sorry, eighth an inch deviation for this part. But what's important is we always say like we sell the ends.
Hmm.
When you're talking about tube designs and manifolds and anything else, what's most important is this end going to meet there, and is the other end going to meet where you need it to be in this assembly. And
Yes.
so we have tighter tolerances on the end points of those designs by nature. So it's something that's very important for us, and that's actually why we also ask for a technical drawing along with your tube, is we really want to understand the critical features of that and make sure that we use those as guidelines during manufacturing.
Yeah, and something else too, Greg, is maybe you're a hobbyist and don't have technical resources to share your own standards. The nice thing about Xometry is we have established standards, right? Which are aligned with industry practices. So our partners will fabricate to Xometry's standardized manufacturing specifications, and your part,
Yeah.
it's going to be good. I mean, the tolerances will be tight, and it'll be representative of what the industry produces.
Yeah, absolutely. And that's actually part of my job sometimes, is helping read through the industry and figure out what a standard looks like. Because a lot
Hmm.
of times when you're working with individual shops, they have their own kind of, silent standard. Like every tube order is a negotiation. And with us, we lay it out for you. And
Yep.
we're always happy to give you the baseline, but we can also go as technically deep as you need in your requirements. So, oh, sorry, Tim, this is on you here, but it's a little bit about CLR here.
Yeah. So CLR, you'll hear the acronym very often in the tube bending world. It's we said it multiple times. CLR is centerline radius. So this chart here is, again, it was our kickoff for auto quote, right? So this chart will represent bend tooling across multiple partners within our network for tube bending. So basically, if you have something that you can design within these ODs and centerline radiuses, we should be able to fabricate it not just with one partner that may be slammed, but multiple partners. So let's see here.
Yeah, this is the
Yes.
general rule, right? The two
Yeah.
times diameter and below
Yep.
6 inch is kind of like in general, and
Yeah.
quarter inch increments. Like we don't usually have like a 1.333 or
No,
something like that.
no. There are
Yeah.
instances where we could find one, but this is a good representation of our partner. So if you design your tubes to these center lines, we can ensure that we can make it. A good rule of thumb too is when you're designing your bends, 2 times the OD for your center line radius at a minimum. The nice thing about that is it reduces extra processes, extra tooling, sophisticated equipment that requires, maybe special mandrels and wiper dies, etc. So if you have a 2-inch OD tube, try designing that centerline radius to 4, and I guarantee you we'll be able to find someone that can make it without extra tooling or added costs or extra scrap laying around because they failed so many times to make such a tight bend radius. And then lastly, keeping that center line consistent on your tube design is the best way to minimize tooling setup costs and reduce the added costs associated with on that previous video. Every time you change that center line radius in the same part, someone's got to put a new bend eye on there and retool the machine and recalibrate the machine. So just a few couple topics here to really keep your design within our guidelines. Next, you'll hear us talk about this, which we did previously. Distance between the bends. So again, multiple bends are great. We like multiple bends. We like multiple bends in and out of plane. So flat tubes and bends that go in multiple different planes. So along with the appropriate center line radius design that we talked about, keeping the distance between the bends is just as important. So the previous video showed that clamp die came in and it grabbed the tube before it made the bend. So that clamp die has to clear the distance between your bends, because if you don't have enough distance between those bends, that clamp die will actually interfere with the previous
Yeah.
bend, and it'll damage your tube and allow our partners to not be able to make it. So again, that two times rule, right? 2 times the OD or more if you can between bends is a really good rule of thumb. Otherwise, you might want to consider putting a weld in there, or we would consider putting a weld note on your quote to say, hey, we can make this part for you, but it might have a circumferential weld in between those bends.
Yeah, and by the way, on that note, we do read drawings, and if
Yeah,
there's welds or something like that, we can incorporate that in. If you have requirements, if you're a welder yourself, then you want to leave ends long on the design that you're
totally.
getting, just ask. We'll incorporate. It actually is nicer because it may save you a business day or so for leaving ends long.
Yep.
And what that means is leaving extra space for you to grind down and fit up just as you need it there. But yeah, there are some things where physically these machines can't do this
Yeah.
without a welding in place, so we also have bends to avoid.
Yeah, so circling back, we gave you some good design metrics and parameters, but there are some shapes, as Greg just mentioned, that it's almost impossible for a traditional rotary drawn machine to do. So this Q-shaped or this knot-shaped tube is almost impossible for like that video that we watched for that machine to make without incorporating a weld or someone getting creative.
Yeah,
So essentially what's happening with this type of a bend is when that bend comes around and goes beyond 180, you have machine interference. So it's just going to start running into those giant hunks of steel that are on the backside of that bending machine and not be able to do it. So stuff like this, knot shapes, bends that come back on themselves, bends that are greater than 180 degrees, try to avoid those as much as possible.
yeah, and that's also where you think about splitting and welding, right? So we
Correct.
can we can make this, right? We can make this, but you
Hmm.
may end up having a weld or two
Yeah.
to make the final design,
Yeah, you could
which
probably make
which is
that too.
okay. We just
Yeah.
wanted to make sure that we're communicative up front about it.
Yep. Good point.
So this is a good time. I see questions coming in. Ask more, please. We love answering questions, and we'll get to as many as we can. I only got a couple of slides left here before we jump into the resources, and yeah, please ask away. But I do want to mention again when I was showing the Xometry.com site, a lot of our job is educating on best practices, industry standards around these different technologies. You may be the best sheet metal fabricator on the planet, but you may not know the design rules for tube bending. Check out our design guide. A lot of what we cover today is on that, as well as even more technically deep information. That's free and available right on Xometry's site under our resources. Or if you go to that solutions and click on the tube bending or tube cutting, you'll find the guide there. We also have a great blog that has case studies and other success stories that come through. as well as product updates. I highly recommend going to our resource page, subscribing to our resources, and subscribing to the blog there. And again, just check us out as a knowledge base, because I think we do a lot of things because we cover an entire industry of manufacturing. So we do beyond just a single shop worth of resources. And speaking of guides, I mentioned we do have the brand new design guidelines and best practices for tube cutting and bending available on our website. Get the guide, check it out. It's under our resources tab. And again, it's something that we could also provide a link for as well later on. With that, I think we're ready for Brad for some Q&A. I have, my CTA for everybody is check out Xometry, upload your files. I know you're fabricating. Sometimes you want a flat sheet or bed sheet next to a tube part for a flange, for example. So I have a promotion code for you, metal tube 75, easy to remember, and $75 off your next custom tube or sheet order. So you can combine those together, and it's available for one-time use, but give it a go.
Terrific. Nice job, guys. That was really thorough and quick. You covered a whole lot of ground.
So much stuff.
Thankfully, we
I'm
do have
breathing
some
right
time.
now. Yeah.
We do have some time for questions, and we got lots of them. So let's
do
in.
it.
Peanut profile tube. Does that ring a bell? Have you had experience with that?
Peanut profile.
Is it like we made some clarification on that because when I read that, I was thinking about something where you kind of have multiple diameters within the same tube. So that may be we may want to see what those requirements are.
Okay.
We can do things like if you're what's it called when you're doing the rounding at the very end of tubes for a fitment. So say you're doing a pressure fitment at the end of the tubes. We can look at the custom end statements as well as threading. So it's just around is it standard tooled or is it something completely custom? And that's what we're going to be looking at there.
All right, maybe Jonathan can elaborate on his question.
Mm-hmm.
You covered tolerances, but what about burr requirements?
Yeah, Tim, do you want to jump on that?
Burr requirement. I mean, our standard practice is to remove burrs. If that answers the question, as simple as that. I mean, tube laser cutting. Let's go ahead.
That's something that would be included, I guess, in the quote if it
was
about...
Yeah, it's standard practice. You're not going to receive a part that's not deburred or full of metal shavings or whatnot. It's standard industry practice and cleanliness. So yeah.
Okay.
Also, sometimes when you order tube, especially like a bent tube, you'll see a lot of times that they'll be individually wrapped. So they'll be we're trying to seal, keep them clean. Even end caps may be involved with those.
All that can be requested just to keep. There's applications where you don't want something inside of a tube, especially in like fluid transfer and whatnot, and we can certainly accommodate.
Okay. So, as the kind of the mediary between the supplier and the customer, who talk about how the transportation of the material is managed, any technical issues that go through you, or is it direct to the supplier? And then how does the user know if the supplier is certified IATF or other certifications?
Yeah, so I'll start with that, the last comment, and Tim, you could add some commentary as well with this.
Sure.
So so part of our network, we have this large manufacturing network. As you add requirements, so the type of tube, the size of tube, we are automatic selecting and down selecting, and that includes shop certifications. So for example, Xometry Inc. We are IATF 16949, we're ISO 13485, we're AS9100D, which includes ISO 9001. We have these ITAR registered. We have these upper level shop certifications. And then we have flow down requirements and agreements. So if you're looking for IATF, and you need that requirement, we're going to do that down select to those groups. And those are going to be the shops that see that and qualify that opportunity. What's really important, though, is we have skin in the game. We're not just tossing over the fence and wishing for the best. Part of our digital platform is good outcomes. And so we are running the QMS, not the individual shops. We're managing and monitoring that. We have an NCMR and RMA policy. So we're going to make you whole if something goes wrong. We're in the physical world. It's manufacturing. Our job is to make it right, but things do happen. And when you're qualifying supplier, it's not about when things go right. Usually it's how they respond when things go wrong. And we want to show best in service for you.
Yeah, in terms of the logistics of executing the project. So when we when our quotes become orders and our partners receive that work, the partner will more often than not, probably, you know, the predominant amount of time, source all the raw material, handle all the internal freight to get that material to their shop, make the part, and then Xometry ships prepaid an ad. So we'll ship it to the customer, then we'll invoice the customer after the fact. If there's issues with fabrication on terms like the project management side of things, you'll work directly with Xometry to get those corrected.
Excellent. So along those lines, there's another question about quality approvals, PPAPs. Is that done directly with the supplier?
Same rules, yeah. So we want to know that upfront, right? So think about when you're building that quote with us, it's your love letter to the manufacturer, right? We don't hide your cards, right? We want to see exactly what you need, and we're going to finalize that quote, incorporate the requirements, including the quality standards.
Perfect. And then there's a bunch of questions on the types of tubing and types of materials, and all of that I'm sure is dependent on the suppliers, and you must have enough suppliers that they can cover the gamut.
Yeah, we can laser cut stainless steel. We can chamfer holes. We can thread holes if it's on there.
Yeah, absolutely. And just the types of materials. So you'll be seeing these on the drop downs as well for material options. So it's within our quoting site too. We have those options selectable as you're working through.
And the question related to maximum OD, I just saw 2 inch. So 2 inches is the max on our auto quote platform right now, and that's just due to the fact that we're continuously building our partner network. 2 inch was a good cutoff to make sure we had a nice selection of tooling. If you need something larger than that, we'll just have to manually quote it for you, but we can do that.
Yeah.
Okay. This one on bending multiple radii in the same tube. I'm assuming that's a thing too, right?
Yeah, we can certainly do it. It's just, you know, there's costs associated with it.
And you'll see that. So if you upload your tube design and you have a different centerline radius, you're going to see that DFM feedback on the analysis. What may happen is sometimes that quotes, you know, but what may happen is you may get an ask, or our DFM engineers on post sale are going to be reviewing your design, your drawing, and we may raise a hand on that to ask a question saying, hey, just want to clarify your needs here.
Right. So how long has the tube bending been a part of the Xometry platform?
When did we officially launch? 6 months ago or so?
Yeah, August of 24.
So a lot of how Xometry works though is we've been bending and making and cutting tube for quite a while.
Yeah.
And we have a lot of processes right now that we're doing that are on our menu. And as we build a customer base and as we see the demand, we're prioritizing what the next process or material or offering is on our website. And so we were seeing like there's especially actually a lot of what I was seeing was in aerospace structural design. You know, and we were starting to see these demands coming through. You know, you get your CNC custom parts, you get your plate sheet cut parts, and then all of a sudden, like there's a few tube things in there. And as we were building those out, we saw the demand to add this to our network.
Okay. I like this question about building gauges, designing and building gauges. I'm sure the customers will do that as well if it's part of the spec, right?
Yeah, like you're talking about check or fit gauge. So I say I have a hydraulic manifold and I do a check or fit gauge.
Yeah.
Yeah, and actually I'll tell this from the other side too. As I came from advanced additive manufacturing, I've 3D printed hundreds of fit gauges for hydraulic manifolds, you know, in the time, because we actually, you know, part of our some of our customers are in the automotive space, and they'll be using our large format 3D printing options to build fit check gauges. So if you're in the market of making check gauges, please take a look at our other services as well.
Perfect. We are over, but I'm going to ask you one or two more questions.
Sure thing.
I understand we're over, and I know people that if you gotta move on. Obviously that's okay, but we've got so many questions, so I'm just going to ask a couple more. So you mentioned ovality, tube ovality. After bending, it shouldn't exceed 10%. The question is that with respect to the diameter, such that the diameter would be squashed by 10%? Is that what that is getting at?
Yeah, so I'll answer that one, Greg.
Yeah, sure.
So it's basically the percent of out of roundness. So think about, you have a bend, you take a pair of calipers and you measure the high spot and then the low spot, right? 90 degrees from each other. So you're basically subtracting that difference between the higher ovality and then the lower ovality, and then divided by the nominal, and it gives you your percent of ovality. So percent of out of roundness, basically.
I think I'm going to make this the last one. I think it's a good question. Can you get multiple bids on these quotes from different manufacturers? He's thinking, and specifically, looking at the trade-off between pricing and lead times.
Yeah. So, I mean, this is actually interesting because this is, Xometry's business model. So what they're asking is, how do I know if your quote's competitive, right? That's what you're really asking there. We are, as a two-sided marketplace, we pay our suppliers. Like we actually know how much it costs to produce these parts, and we use data science and machine learning to train against this, as well as we're using matchmaking. So we're not throwing this out like to all suppliers. We're throwing work out to suppliers that do that work well. So usually if a supplier has work in their sweet spot, they're usually able to make it more consistent, better, faster, and cheaper. And that's the data that we're training on. So that allows us to offer a wide selection of manufacturing options and have competitive pricing for each one of those there. So instead of a bid war where it's a race to the bottom, what we're doing is we're using market-based pricing based on parts like this on Xometry's manufacturing marketplace cost this much, price to the customer. That's how that works with the AI machine learning. We also have the Thomas side. So Thomas is a supplier directory. You could go, that's a great way to down select and find suppliers if you're looking for those individual transactions. But for, a lot of Xometry's value prop is the fact is we're using AI, machine learning, data science right at the heart of the procurement process.
And there is opportunity to give feedback on lead time within your quote. So if you need something that is, expedited, that you can't maybe work towards a standard, we can certainly price that appropriately, right? I mean, our partner network allows us to do that as well.
Yeah, absolutely.
Cool. Terrific. Well, we could probably go on and on here, but unfortunately we are at the end of our time. So again, great job, Greg and Tim. Thank you so much for a really interesting and useful, I think, presentation.
Thank you for having us.
Yeah, you bet.
Sure
To
thing.
our audience, as always, we thank you for attending the program and hope that you all found it to be a valuable experience. Again, as I said earlier, we'll have an archive of this webinar on our website soon. And when that's ready, you'll all get an email from us telling you how to access that. Then you'll be able to review it and maybe share it with others within the organization. So again, thanks to everybody for being here. Thank you guys for presenting today. Close your browsers now and have a great afternoon.
Cheers.
All right. Thanks all.
Pappy's going on there. All right. Take care.